Alright, curves of dimensionality. What's the problem? Well, in high dimensions, all points are far from each other. So Euclidean distance kind of loses its effectiveness. So you cannot apply Euclidean distance in high dimensions. Because in high dimensions, all points are far from each other. I know it's difficult to grasp, but we will try to show you by intuition. Yeah. So let's try to explain this. So we take an example of 10 pictures. We have cats and dogs, 5 each, and we want to separate these. We want to create a decision boundary that separates these classes. If you try to do it in one dimension, and here you have a line of 5 units, you could basically put all these dogs and cats on this unit. However, I cannot find a line that separates the cats from the dogs. So I cannot solve this with a linear classifier. The densities, well, I have 10 samples and I divide by 5 equals 2. So the density is 2. I have 5 length units, that's the distance, and I have 10 pictures to divide over these 5. Okay, let us take a look at a two-dimensional case. From what I've drawn here, again, you cannot separate these classes with a straight line. It's just not possible. So you're gonna have to do something like this. To separate the classes. What's the density? Well, here you're going to divide by 25. And there is 10 samples to take. So you see the density is already reducing. Alright, when we look at the 3D case, we can actually separate now the cats from the dogs. You have a hyperplane here that goes diagonal like this. And you can have the cats here and the dogs there separated by this hyperplane. This you call a hyperplane. Hyperplane. That's a term we're going to use frequently in classification problems. And the density, of course, is 10 out of 125 is 0.08. Now, if we go 4-dimensional, your density will be 0.016. 5-dimensional, it's gonna be 0.003. So you can see the higher the dimensions, the lower the density. So we started here at 1D with a dimension of 2. In 2D was it 0.4, roughly half. So you see that it's quite steep. It goes very, very steep, and that should give you an idea that in high dimensional space, all the points are so far from each other that it doesn't make sense to talk about distance anymore. Okay, good. That was the first algorithm, a pretty easy one. And we will do a coding exercise on that algorithm, so to make you a little bit more familiar with how machine learning and coding is working. See you next time.